Let's talk about, the future of finance and like how we should be more customer-centric in Web3, right? But before we go into that, let me introduce the wonderful, almighty SLALayer team who actually won this hackathon. Woo! A round of applauses. Thank you, thank you, thank you. Okay, so now let's talk about the real example. Next slide, please. Okay, so the users are actually suffering. The users are actually suffering Web3, like, let's take the Uniswap example. The Uniswap was apparently down, not because they did something wrong, but because their graph was failing for all the time. And like, in the end of the day, my question is, whose neck is on the line? Why the end users are suffering while it should be basically the people who are failing to provide their service to be responsible for that, right? So my question is there any mechanism to actually compensate the end users? No? Why not? Shouldn't we like focus on our end users, on our customers? Isn't it the whole goal of making business? Next slide, please. So that's what we actually want to introduce. We want to bring in SLAs. We want to bring the high uptime guarantees that are bonded, that are like financially bonded, that, okay, if the downtime happens, there is actually somebody who will be caring about that, not just because somebody is like losing money, but because like the end users will get also their part of like compensation, because users shouldn't be the ones to suffer from the financial losses. We want to be customer-centric, right? So let's talk about how the user flow would look like. Basically, the user is the one who is registering and making a deal with an indexer or with storage provider. Just think about general use case, right? The user is registering in, opting in for higher SLAs. And then if indexer is ready to provide the service, right, and if there is a financial guarantees that coming from AVSs, right, then the three-way deal is being made. Then the indexer is incentivized to provide better service by the payment that is made by user. The operators from the eigenlayer are incentivized to provide a better service because they will need to stake with the indexers that are really providing good service. And the end users, in this regard, this is the most important part. The end users are actually going to get compensated if downtime happens. So guys, the story is the following. If any one of you are actually suffering from the same problem, are any of you who want to contribute to the success of DePIN, any of you who develop the subgraphs, find me, contact me, talk to me. Guys, please, the last slide of the presentation. There is going to be one beautiful, like, the very last one. No, this is the second one. Yes, thank you so much. So I'm going to show you the link, right? Scan the link, talk to us. Let us know what is your pain point. We are here for the users. We are here to solve the end users' problems. And yeah, basically, thank you for your attention. Maybe if you have few more minutes or 1 more minute at least, like maybe one question. No? Okay, anyways, please contact us. Thank you. Oh, okay, question? Yeah, I mean, like, we can talk about economics. It's pretty much produced already, like, but I'm not sure if we will have enough time for that right now. But let's catch up right now and talk about that, okay? Thank you, everybody. Thank you for your attention. Thank you for making the Web3 better and better every day. Thank you, everyone.
Okay, next up is Renç, co-founder of Giza.
Hello, everyone. Oh, I can't That was great at its own part, on its own way. Really appreciate it. Thank you so much, everybody, for joining in. My name is Renç. We'll find the presentation soon. I didn't have the video just because I thought something like this would happen. But Giza, actually, what we're doing is we're trying to bring Web3 to life by building agentic applications. We want to make Web3 smarter. The Web3 that we imagine has agents as the main interface that processes user intents and turns them into unceasing on-chain actions. Why is this important? Next slide, please. Do I have the thingy? Perfect. I think there has been a lot of conversations on agents recently. There's a lot of noise as well. And I think YQ also set up the stage perfectly for me to join. I think this part has not been really talked enough about. Most of the usage on Web3 right now is incentivized one way or the other. Most of the stats are, kind of like synthetically driven. We believe it's time to change that. Agents don't wait, agents don't care, agents don't sleep. Agents will be the main drivers of organic usage through smart decision making and intellectual capital allocation. We want to basically replace incentives with smart decision making and bring organic usage back to Web3. Yes, perfect. So in order to build an agentic ecosystem, a sustainable one, you need to provide certain things. You need to provide trust, you need to provide automation, you need to provide optimization, and while doing all of these things, you also need to let the user still be in control. That's why at Giza we build this stack. It is quite complementary to all of those things. There are session keys and smart accounts that basically provide high-level and granular control between the agent and the user. There's the agent logic, which is the core decision-making program that we build. And there is verifiable computation cryptographically through ZK proofs that enables the agent stays between the rules that is set by the developer. And as the last part, we have the execution layer. And the execution layer is where the Giza protocol and the AVS structure and our eigen layer comes into play. We want to decentralize the execution layer and of the agents. So these agents are not executed by a central entity like us, which is the current situation. And we have more uptime, we have more decentralization, we have more transparency, and we scale to many, many more users. This is what we built in the hackathon. It was a part of our development sprint. And as with all the hackathons, it did accelerate a lot of things, that it did answer a lot of questions. In the remaining few minutes, I would like to ground this conversation a little bit and talk about an agent that we're going to be launching in a few days. It's called ARMA. It is basically an automated stablecoin yield optimizer. And there's certain problems that we are solving for certain stakeholders, which are users, protocols, and the ecosystems that we build in. We believe it's a win-win-win situation. I will quickly walk you through it. ARMA is aiming to solve the fundamental problem of DeFi, which is its overhead. To me, DeFi is an incredible technology. Like decentralized finance is great, but at a product level, I find it quite inhumane. It takes hours and hours and hours for a user to onboard themselves to a DeFi protocol. Another hour for them to feel safe about using it. More hours to start setting up your wallet, start using everything, and countless hours to monitor different DeFi protocols if you're using them. And at the same time, in the end, what you don't get is that you don't even get the best DeFi outcome. We want to completely change that, and ARMA does that. Instead of having one user going to 3 different protocols and signing 30, 40 different transactions, we bring the time spent to onboarding to DeFi from hours to minutes. You only have to delegate this task to the agent, and agent will sign these transactions autonomously for you. Agent will make sure you have the best yield at any time for you. It will calculate the gas optimizations. It will only transact when it is profitable for you. So for the user, what we're optimizing is 2 things. And the 2 things that they care about the most, their time and their positions. For the protocols, it means more volume, because a user only interacts with a protocol 2 to 3 times a month. An agent interacts with protocols 30, 40 times a month, because they drive continuous optimization, and continuous optimization means sustained network activity. The last part is the protocols, the partners. For the partners, what we bring is increased network value, more actions, more capital allocation, more capital movement, more organic usage, as we mentioned in the beginning. That's why it's a win-win scenario. For us, this is what application level innovation at Web3 looks like. Better products for the users and more usage for the ecosystem. We're going to be launching the agent in a few days. You can follow us on Twitter. You can add me on Telegram. You can come and talk to me. Thank you so much for your time. I will leave it to the next speaker.
Thank you. Thank you. Okay, last and final pitch is Akshat Mishra, CTO of QuillShield AVS.
Hi. I guess the last two projects have set the bar too high, and I'll do my best to keep you guys entertained. Yeah. So this is our QuillShield AVS, bringing verifiable and risk-ensured security on-chain. So let's get started with discussing the problem. So Web3 has a very fundamental problem of security. You don't really know what's the security of the dApps that you're interacting with. You're basically assuming that they would work as they should. And even though the code is open source, nobody really bothers looking at it to see if there's any coded malicious activity inside of it. So what QuillShield does is it brings audits on-chain in a way that the end users can verify that. And so the first problem is the audits that happen in Web3, they provide limited assurance and they're not foolproof in terms of security. So an audit does not guarantee that your project is not going to get hacked. And there's heavy reliance and trust in centralized auditing parties. So let's say you go to an auditing company and the auditors do find some bugs, but instead of telling you, they can choose to keep it to themselves and wait for your project to go live and then use that information to hack you guys. The third is lack of economic insurance. So these audits don't really provide you anything if you think about it. If you're not finding any vulnerabilities and if you're missing on some vulnerabilities, you should be at least getting some guarantee after the audit that your project is secure in case things go wrong. And the users obviously don't have any way to verify the security of a protocol that they're interacting with. So how do we solve this? So the solution is Quill AI AVS. And what we are doing is we are bringing verifiable AI-powered audits. So I feel like there's a lot of noise around AI agents already. And we're using AI agents to power the security of Web3. So the first thing that we're doing is we're bringing AI-powered audits. And these audits are being run by the eigenlayer operators. So we can support multiple different chains. We can also provide economic risk insurance. So let's say you do conduct your audits through our platform. For the risk score that you get, you are eligible for some insurance that you can avail. So in case your project gets hacked, you can file a claim in our platform that you want your insurance claim, and we're going to process it for you. We're using some frontier AI models, and we have fine-tuned it ourselves over a corpus of security data. So these models keep getting better and better in terms of auditing your smart contract and finding bugs. Now that's really interesting because we are solving a lot of problems with centralized audits. The centralized audits are not only slow, they're choked, and they're pretty expensive for the end users. So this is kind of democratizing security. So how do they work? It's pretty simple. You create an audit. The end users can request for an audit in our auditing platform. The task will be processed by the AVS operators who are looking for these audits. And after the audits are conducted, the rest of the eigenlayer operators are actually going to verify whether the audit was conducted successfully or not. So the way we are doing it now is that every operator runs the same auditing software. And if it's the same software, the results should be the same for the given contract. Now in the future, obviously, we're looking at more intersubjective ways of verifying these audits, which is an interesting thing to look into. Now, here's the insurance part, and the insurance part is pretty simple as well. Now, let's say you do want to get yourself some insurance. What we want to do first is ensure that your contracts are eligible for insurance. And for that, you need to have a good security score. For something as poor as 80% or 60%, we are not going to provide insurance. Now, then you can file your claim. Let's say your project does get hacked. You have to file a claim, and that claim will be processed by the eigenlayer operators themselves, who are going to look whether your claim stands and your protocol was actually hacked. So the future scope is pretty simple. So we're looking at ways in which we can provide AI-powered insurance verification and claims so that the AI agents can autonomously find whether something was hacked or not. Now, this is both based on off-chain and on-chain data. And intersubjective ways of audit verification. So the idea could be multiple different operators could be running their own version of agents, and each of those agents would compete to give you the best audit. And these agents could independently also verify the other person's audit to say if the bug actually exists or not. So what we are building actually is part of a greater picture called the Quill AI network, where we are powering the security interests of all of Web3. We feel like it's not a localized problem, it's a big issue, and for that we are building a foundational model on which you can fine-tune your own models and you can build any sort of agent that's focused around security. Now, this includes stuff like due diligence agents. So if you don't know what's the security behind the token that you're buying into, if it's a honeypot, if there are ways and mechanisms inside through which you could be prevented from selling the token once you buy it, QuillShield and Quill AI Network is going to help you with its agents. So we are using EigenLayer for the trust and security, and we have our own compute nodes which are going to be running these agents. And so yeah, that's pretty much it. Let's bring verifiable security on chain, and I would love to answer any questions anyone has. Okay, we don't have the time for it, sorry. If you guys want to ask any questions, I'll be here for a while. Okay.
Thank you, Akshat.